Greetings, programs. Welcome to Rationality, From AI to Zombies. Chapter 39, Lawful Uncertainty. In Rational Choice in an Uncertain World, Robin Dawes describes an experiment by Tversky. Many psychological experiments were conducted in the late 1950s and early 1960s, in which subjects were asked to predict the outcome of an event which had a random component, but yet had a base rate predictability. For example, subjects were asked to predict whether the next card the experimenter turned over would be red or blue, in a context in which 70% of the cards were blue, but in which the sequence of red and blue cards was totally random. In such a situation, the strategy that will yield the highest proportion of success is to predict the more common event. For example, if 70% of the cards are blue, then predicting blue on every trial yields a 70% success rate. What the subjects tended to do instead, however, was match probabilities. That is, predict the more probable event with the relative frequency with which it occurred. For examples, subjects tended to predict 70% of the time that the blue card would occur and 30% of the time that the red card would occur. Such a strategy yields a 58% success rate, because the subjects are correct 70% of the time when the blue card occurs, which happens with a probability of 0.7, and 30% of the time when the red card occurs, which happens with a probability of 0.3. 0.7 times 0.7 plus 0.3 times 0.3 equals 0.58. In fact, subjects predict the more frequent event with a slightly higher probability than that with which it occurs, but do not come close to predicting its occurrence 100% of the time, even when they are paid for the accuracy of their predictions. For example, subjects who were paid a nickel for each correct prediction over 1,000 trials predicted the more common event 76% of the time. So, do not think that this experiment is about a minor flaw in gambling strategies. It compactly illustrates the most important idea in all of rationality. Subjects just keep guessing red, as if they think they have some way of predicting the random sequence. Of this experiment, Dawes goes on to say, despite feedback through 1,000 trials, subjects cannot bring themselves to believe that the situation is one in which they cannot predict the result. But the error must go deeper than that. Even as subjects think they've come up with a hypothesis, they don't have to actually bet on that prediction in order to test the hypothesis. They can say, now if this hypothesis is correct, the next card will be red, and then just bet on blue. They can pick blue each time, accumulating as many nickels as they can, while mentally noting their private guesses for any patterns they thought they spotted. If their predictions come out right, then they can switch to the newly discovered sequence. I wouldn't fault a subject for continuing to invent hypotheses. How could they know if the sequence is truly beyond their ability to predict? But I would fault a subject for betting on their guesses, when this wasn't necessary to gather information, and literally hundreds of earlier guesses had been disconfirmed. Can a human be even that overconfident? I would suspect that something simpler is going on. That the all-blue strategy just didn't occur to the subjects. People see a mix of mostly blue cards with some red, and suppose that the optimal betting strategy must be a mix of mostly blue cards with some red. It is a counterintuitive idea that, given incomplete information, the optimal betting strategy does not resemble a typical sequence of cards. It is a counterintuitive idea that the optimal strategy is to behave lawfully, even in an environment that has random elements. It seems like your behavior ought to be unpredictable, just like the environment. But no, a random key does not open a random lock just because they are both random. You don't fight fire with fire, you fight fire with water. But this thought involves an extra step, a new concept not directly activated by the problem statement, and so it's not the first idea that comes to mind. In the dilemma of the blue and red cards, our partial knowledge tells us on each and every round that the best bet is blue. This advice of our partial knowledge is the same on each and every round. If 30% of the time we go against our partial knowledge and bet on red, then we will do worse thereby. Because now we're being outright stupid. Betting on what we know is a less predictable outcome. If you bet on red every round, you would do as badly as you could possibly do. You would be 100% stupid. If you bet on red 30% of the time, faced with 30% red cards, then you're making yourself 30% stupid. When your knowledge is incomplete, meaning that the world will seem to you to have an element of randomness, randomizing your actions doesn't solve the problem. Randomizing your actions takes you further from the target, not closer. In a world already foggy, throwing away your intelligence just makes things worse. It is a counterintuitive idea that the optimal strategy can be to think lawfully, even under conditions of uncertainty. And so there are not many rationalists, for those who perceive a chaotic world will try to fight chaos with chaos. You have to take an extra step and think of something that doesn't pop right into your mind in order to imagine fighting fire with something that is not itself fire. You have heard the unenlightened ones say, rationality works fine for dealing with rational people, but the world isn't rational. But, faced with an irrational opponent, throwing away your own reason is not going to help you. There are lawful forms of thought that still generate the best response, even when faced with an opponent who breaks those laws. Decision theory does not burst into flames and die when faced with an opponent who disobeys decision theory. This is no more obvious than the idea of betting all blue, faced with a sequence of both blue and red cards. Each bet that you make on red is an expected loss, and so too with every departure from the way in your own thinking. How many Star Trek episodes are thus refuted? How many theories of AI? Here ends chapter 39. Now for my thoughts. Yeah, I've encountered this. It's a hard habit to break. I have a friend who shall remain nameless, because he hasn't given me permission to share this. But this friend of mine has made quite a lot of money gambling. And he gambles on horses and such, so it's not about skill, it's about doing the mathematics. And he has pointed out that it is entirely possible to win consistently, but you have to restrain yourself. You have to not go for the big score when you think you might have a chance. You have to force yourself to stick to the boring old, very small but significantly more reliable minor gains. And this is the same sort of thing here. It doesn't take a genius to look at 70% blue cards and 30% red cards and work out that the winning strategy is to just say blue all the time and only be wrong 3 out of 7 times. That doesn't take genius to work out. The trick, I suspect, is to have the willpower to see a run of red cards pop up, as is likely to occur randomly from time to time, and still bet blue. Because unless the person you're talking to is being deliberately dodgy, you still have a better chance of being right no matter how many red cards have gone by. Worse, the more red cards come out, the more likely it is, in a fixed set, that the next card is going to be blue. So, keep betting on blue. Basically, fight the little monkey in the back of your head that sees all the red cards and resist the urge to scream red for the next card. Because mathematics doesn't care how you feel about it. It is what it is. And my gambling friend would simply look at the odds, look to see if there's anything shifty going on, and if there's not, he'd just shrug and say blue over and over and over again until he had enough money and he left. And I think I can learn a lot from him, and so can you. Okay, that's all for this episode. Bye for now.